All right. Polynomial functions. This is 5.1. Polynomial functions. Polynomial functions are functions that look like that. An x to the n plus an minus 1 x to the n minus 1 plus a1x plus a sub 0. These are all real numbers. an minus 1, and so on, a1, a sub 0. Those are all real numbers, and these are whole numbers. So the power should be a whole number, and the coefficients are any real numbers. This is obviously a polynomial function. This is a polynomial function. Actually, these are all polynomial functions, but these ones are not polynomial functions. Square root of x, x squared minus 2 divided by x to the third minus 1, or if I write cube root of x, or I write y equals absolute value of x, these are not polynomial functions. So polynomial functions are nice behaving functions. They look like this, okay? And polynomial functions can be written in factored format or in expanded general format. Okay, sometimes you see functions as factors, powers of factors. Sometimes you get polynomial functions are in standard form. Okay, once you recognize a polynomial function, let's talk about how to find two things. Those are the leading coefficient and the degree. So you have to identify the leading coefficient and degree of a polynomial function. Leading coefficient, what's the degree? Degree is the highest exponent of x. So the degree of the first polynomial function is 4. Degree, it's not in, order, okay? The degree of the second polynomial function is 4 again. The degree of this polynomial function is 1. The degree of this polynomial function is 0, and this we say no degree. That is just the x-axis. I of x equals 0. That is just the x-axis. It has no degree. If it is just a constant, its horizontal line, degree is 0. So this is degree 1, degree 4, degree 4, these polynomial functions. Those are the degrees. Now, the leading coefficient is the coefficient of that term, which determines the degree. So the leading coefficient of this polynomial function is negative 3. That can be any real number. A is negative 3 because it's negative 3x to the 4. That term determines the degree.
So it's the number next to x.
Correct. That's the coefficient in front of it. The leading coefficient of that polynomial function is square root of 2. This one is 9, and we don't talk about leading coefficients if it's a constant function or the x-axis. So that's how you find the degree and leading coefficient if it is in expanded form. How about if it is factored form? What's the degree of that polynomial function? It's 5, yes. Degree, we use the letter n. So n is 5 for this function. If you expand that, you get x cubed times x minus 1 squared. That is x squared minus 2x plus 1. So it's going to start from x to the 5th term. Yes?
For f, would degree be 3? Where did you get n equals 5?
Because 3 plus 2. Because when I expand, I get negative 2x cubed times x squared minus 2x plus 1, which I get negative 2x to the 5, see, plus 4x cubed minus 2x cubed. Sorry, the second one is fourth, minus 2x cubed. So if it is in expanded form, then you can easily identify the degree. But if it is in factored form, you have to add the exponents of each of the factor.
You
Add them. So 3 plus 2 is 5. Because when you multiply exponents, you add them. So degree is 5. Leading coefficient, we're going to use this notation, a sub n, and that is negative 2. A sub n is the number in front of it, so it's negative 2. That's the leading coefficient and the degree of a polynomial function. So we should be able to identify them. Yeah.
So for the leading coefficient, if it's a constant function,
Then we don't talk about that because it's no x. No degree is y equals 0 or f of x equals 0. That's called a zero function, and the graph is simply the x-axis. If y is a constant, that's what we saw here, which is e, g of x is 8. That is f of x equals a sub 0. It's an example to that. It's a constant function, and its degree is 0. Then we have a linear function. Here we had a linear function which was 9x. And that's called a linear, and the graph is a straight line. Its degree is 1. Then we know quadratic function if the degree is 2. It's a parabola. We'll learn those. And after that, cubic function, let's just call it polynomial functions. And if the polynomial function is factored format, you simply add the exponents. Okay, so that's why we added 3 and 2, we got 5. We already did that example. We've got the degrees and leading coefficients of those polynomial functions. The next one is the graph of a polynomial function is a smooth, continuous curve. So when you graph a polynomial function, don't make any corners or cusp or hole or gap. Just draw a continuous, smooth, continuous graph, okay? That's a polynomial function. So this can be a polynomial function, but that's not, because it has everything. Has a corner, has a cusp, it has a hole, has a gap. So that is not that cannot be the graph of a polynomial function. Now zeros. The next one is zeros of a polynomial function. Zeros are exactly same as x-intercepts. So this is just a fancy word. Zeros are same as x-intercepts. And you know how to find the x-intercept. You put y equals 0. Or you set f of x equals 0. And you find the x values. Those are the x-intercepts. X-intercepts are exactly the same as zeros. And we can say all these are all the same meaning. X equals r is a 0. X equals r is an x-intercept. What does that mean? F of r is 0. It also means x minus r is a factor. It also means if you solve the equation f of x equals 0, you get R as a solution, and it touches or crosses the x-axis at that point. Those are all the same thing, okay? All those 6 statements mean the same thing. You can say it's a 0, you can say it's an x-intercept, you can say f of that number is 0, and x minus that number is a factor. It's a solution when you set f of x equals 0. And you know that x-intercept either it touches or crosses the x-axis. See, these are all x-intercepts. This is crossing, crossing again. This is simply touching. This is crossing. Okay, so x-intercepts or zeros, the graph can touch or cross.
How do you determine whether it touches?
Okay, that's the next subject. Okay, we're going to look at something called the multiplicities of the zeros. Okay, multiplicity. What is this multiplicity of a zero? The multiplicity of a 0 is the exponent of that factor. Okay, suppose you have x equals a number is a 0, right? If x equals r is a 0, then we know that function has a factor which is x minus r, right? It has to have a factor x minus r. Otherwise, you wouldn't get x equals r as a 0 because we are setting this to 0 to solve. And there will be an exponent for this. That number is called the multiplicity. The exponent of that factor. If that multiplicity is even, the graph touches and turns back. If that multiplicity is odd, the graph crosses. So how would you determine without graphing? You factor. This is not factored, so we are going to do that. We're going to factor that first. We need to see the factors. Then you look at the exponents of each of those factors. If the exponent is even, it simply touches. If the exponent is odd, it crosses. So let's see how does this work.
Even it touches?
Yes.
And then odd it
It crosses, yes.
What?
The multiplicity. So I'm going to factor this. How would I factor? What's common? X. Then x squared. Go ahead. Minus 2x plus 1. I can factor again. This is x minus 1, x minus 1. But you may want to write that as an exponent. So I get x minus 1 squared. If something repeating, you have to write that as exponent. Don't write x minus 1, x minus 1. Because we need to find the multiplicity. Multiplicity means how many times it's repeating. Okay, that's the exponent. So if I find the zeros, I set this equal to 0, right? That's how I find the zeros. And obviously, the zeros are, from here, I get x equals 0. From here, I get x equals 1. So those are the zeros. Yes?
What do you mean you got x equals 0 and x equals 1?
I said that 0. That means each factor is 0. So the factor x is 0. The factor x minus 1 squared is 0. That means x minus 1 is 0. So x is 1. Okay, those are the two solutions. Yes? 0 is 1 because the exponent, if you don't see the exponent, it means it's 1.
So there's going to be 2 answers that's 1.
Huh?
So the multiplicity of 1 is 2?
2, yes. Multiplicity of 0 is 1. Multiplicity of this 0 is 1. Multi is 1. Yeah, because it doesn't repeat. Just one time. That's it. And this one is, multiplicity is 2, which is even, right? which is even, and this one is odd. So what can you say? The function touches or crosses at 0? Crosses. The function touches or crosses at 1? Touches. So we know that, right? Our final goal is to graph. We are getting there. So first step, we find the zeros with the multiplicities. And we decide at each 0, what does the graph do? Does it turns back or it crosses? So that's the first thing. Lastly, we're going to graph, okay? So, yes.
So if the multiplicity was 3,
Then still it crosses because it's odd number.
Or I mean, if x was equal to 2, then the multiplicity would be 3.
Say it again.
If x were to equal 2, for is the multiplicity.
If this is 3, then the multiplicity would be 3. If this is 3, then the multiplicity would be 3. How many times it repeats? That's the multiplicity. So here we don't see the multiplicity, so it's 1. There is no exponent, means it's 1. So it crosses at 0 and it touches at 1. So we have to factor to see that. See, this is already factored, so you don't have to do that. You can simply list the zeros and their multiplicities and tell me whether it touches or crosses. So what is the first 0? X equals 1, right? The second 0, x equals -1. Third 0, x equals 3. Here there is no x with -2, so you simply ignore that. If there's a number, it doesn't give you any 0. Only there has to be an x, then 0. You can count 0. What is the multiplicity of the first 0?
I don't understand what you just said. X equal 1.
Because I set this to 0, right? That means I can set each factor to 0. So I get x equals 1. Then I set x plus 1 cubed to 0. So I get x equals -1, right? Then I set the last one to 0. I get 3. That's how you find the zeros. You set each factor to 0. Okay. All right, let's write the multiplicities now. Multiplicity is 1 because the exponent is 1 there. So what does it do? Crosses. Crosses what? The x-axis, okay? The graph crosses the x-axis. -1, multiplicity is 3. It does the same. Crosses, yes. Crosses the x-axis. That's -1. What's the multiplicity of this one? 2. So, 4, which is even, so it touches. Multiplicity, we don't want that number. We just need to know whether it's even or odd. If it's even, it touches. If it's odd, it crosses. Okay? We're not interested in the actual numbers. Just even or odd. But we need those numbers to graph because those are the x-intercepts. Okay? The next thing is end behavior or the leading coefficient test. There are 4 cases for this leading coefficient test. To find the end behavior, we look at the 2 things, which is the leading coefficient and the degree. And you know how to recognize them, right? You know the degree, how to do that, and you know the leading coefficient. First, we look at if the degree is odd. For example, if I write a polynomial function, f of x equals 3x to the 5 minus 2x squared plus 1. This is odd. Degree is odd. That is case 1. In that, you can separate that into 2. If this number is positive or negative, the leading coefficient. Okay? So first you look at the degree. If the degree is odd, and the leading coefficient is positive, then the right end goes up, the left end goes down. So you're going to graph the function something like this. We don't know how many these turning points, but you rise there and it falls there. Okay, right end rises, left end falls. The middle part we don't know. It depends on how many, we don't know that. But we know the ends. The right end rises, left end falls. How about if this number is negative? Then the opposite. Left end rises, right end falls. Just the opposite. So, if the degree is even, the two ends behave in opposite direction. It's positive, then rises, falls. If it's negative, then falls, rises. Okay? If AN is positive, right end rises, left end falls. If AN is negative, left end rises, right end falls. Not bad, right? Now, if it's even. If it's even, either both end rise or both end falls. And when does that rise happen? If a leading number is positive. The leading number is negative, both ends go down. That's end behavior. Okay? So first we talked about the zeros, multiplicities, touching, crossing, stuff. Second, we are deciding how the ends behave by looking at the degree and the leading coefficient. We look at those two to determine how the ends, only the ends, I don't know the middle part, the ends behave. So we're getting there, okay, to graph a polynomial function. So this one is all even degrees, right? All even, because look at that, the ends behave the same way. These three, the leading coefficient is positive. There's only one with the leading coefficient negative. And these are, I have only one, I could draw more. Yeah, I can draw one like that. That's odd degree, right? And this is AN negative. Here AN positive. Odd degree. Odd degree rises and falls. Can you tell me the end behavior of this one? We can just draw like that. This is n is 4, which is even. What is the leading coefficient? 1, which is positive. So, yeah, very good. Both ends rise. Both ends rise. Leading, degree, 3, which is odd. Leading coefficient is negative 3, which is less than 0. So, right end, yeah, like that. Right end falls, but the left end rises. That's the end behavior. We have one more thing to do, the maximum number of turning points. Turning points are those peaks and valleys. A function can have at most n minus 1 turning points if n is the degree. At most, that doesn't mean it has to have n minus 1. It could be any number less than that. But it cannot have more than n minus 1. For example, a polynomial function of degree 4 cannot have 4 turning points. Can only have up to 3. Can have 1, 2, or 3, but not 4 or above. So n minus 1. Those are the things we learn about polynomial functions. Now we're going to put these together and graph. That's called analyzing a polynomial function. And you will get 2 of these on the test. 1 expanded format, that means you factor, and 1 already factored, like that, okay? So 2 questions from this section. You're going to do everything, and I will tell you the steps, okay? Find the end behavior, find the y-intercept. Y-intercept, that's easy. You put x equals 0. Then find the zeros, maximum number of turning points. You put those together and give me a rough sketch. Not exact, just a rough sketch. Okay? So 2 questions. All right, let's start from this one. Step 1 is find the end behavior. So step 1. End behavior, I need the degree and the leading coefficient. What's the degree? N is 4 and leading coefficient is positive. So I know I'm going to graph like that. Okay. I'm going to graph. Which is greater than 0. Yes. Yes, I can write that. 1 greater than 0. Yeah. Yeah. So step 2, I need to find the y-intercept. Y-intercept is simply f of 0. What is f of 0? Plug in 0. 0, right? So the origin is the y-intercept. Y-intercept, not x. X-intercepts are zeros. Y-intercept is something different. Step 3, I'm going to find the zeros with the multiplicities. To do that, I have to factor this. And you're going to help me to factor. How would I factor this function?
First you take out x squared.
X squared. Then? Yeah.
And
I'm not done, right? I can do again. How?
you factor x
Mm-hmm.
minus 4, which is x plus 2x minus 2.
There you go. So you have to factor completely. Uh-huh.
For step 2, did you do x to the 4th is equal to 0?
Both, yeah. 0 minus 4 times 0, which is still 0.
And then you did negative 4x squared is equal to 0?
No. I just plugged in 0. So it's going to be 0 minus 4 times 0, which is f of 0. F of 0 is plugging in. That's y-intercept, not the zeros. Okay, tell me the zeros, multiplicities, touching, crossing. Let's write zeros. First 0. 0 number 1, which is x equals 0. This. Okay. And what is the multiplicity? 2. What does it do? Touch. Touch. Touches. Any question there? Yeah.
For the zeros, x equals 0. How did you get that again?
You set each one to 0. So that's when you put it to 0.
Okay.
Yeah. What is the next one? Negative 2. What's the mult? 1. So what does it do? Crosses. Next 0. 2. Multiplicity same. Crosses, right? Because it's 1 again. That is step 3. Yes? Step 4, maximum number of turning points. That you simply subtract 1 from the degree. What is that? N minus 1. What's n? 4 minus 1, which is 3. Okay, maximum number of turning points. That's step 4. And this, so don't draw a function with more than 3 turning points. Doesn't have to have 3, could be 2, but the maximum is 3. Can we graph? So I want you to plot the points you have. You have 3 zeros and one y-intercept. The zeros are 0, 0, 2, 0, negative 2, 0. Then all I'm going to do is I'm going to use the end behavior and touching crossing property to sketch a rough sketch. I'm not doing exact graph. No, doing only a rough sketch, okay? So I know this end goes up, so it comes down. Does it touch or cross at 2? Crosses, comes down, right? Then it comes back, it touches, then again it crosses and goes up. That's the graph. And how far this goes down, we don't know. So as long as it goes down, I'm good, okay? You don't have to look at the calculator. Please don't actually, because it can mislead you. If you look at the graph this on the calculator, it may see like this. That doesn't mean it goes through the x-axis. If you zoom in a few times, you can see it's crossing a little bit, okay? So do not, please, just a rough sketch is enough.
Why do you do 4 minus 1?
That's the formula to find the maximum number of turning points. It's degree minus 1.
Degree.
Yes, degree is 4 here. So 4 minus 1. So just try a rough sketch, okay? This, if you want to go down like that, that's fine. Okay, or you just want only this much, that's fine. Because we're not finding any points in between those to see how far it goes down. As long as it's touching, crossing, you got right, then we're good. So this is just a rough sketch of that polynomial function. So that's how you do if it is not factored. Here is another one. There is one more. And I have 2 that's on 1 that's already factored. So I think I can do one more. So either 2 or 3. Which one is difficult to factor? So 2 or 3? Looks like 3. Okay, let's do 3. Okay, let's do 3. This is actually, if I write in standard form means decreasing order of degrees. If I do that, this is how the function looks like. Is that right? Is that right? That's how it should be. If I put the highest degree term first. Right? That's what the function is. Okay. Step 1. What is step 1? End behavior. Degree is 4, which is even. Leading coefficient is negative 1/2, which is negative. So, yeah, goes down. That's how your graph is going to look like. Step 2, find the y-intercept. Y-intercept means just plug in 0. You're finding f of 0. Put 0 for x. What do I get? 1/2. So the y-intercept is 0, 1/2. 0, 1/2. Let's plot that right there. See? That is the y-intercept. 0, 1/2. Now I need the zeros. That's the part I have to factor. Step 3. Step 3 is the one I have to factor. So my function is f of x equals negative 1/2 x to the 4 plus 1/2. Okay, if the leading term is negative, you may want to factor out a negative common factor. What is the negative of the common factor? It's going to be minus 1/2, okay? So we do that, remember, factor out a negative if the leading term is negative. That helps you to factor better. So it's going to be x to the 4 minus 1 because I moved a negative out, right? X to the 4 minus 1. Just factoring, which is negative 1/2. Okay, how would I factor x to the 4 minus 1? X squared plus 1, x squared minus 1. That's how you factor x to the 4 minus 1. X squared plus 1 we cannot factor. It's prime. However, x squared minus 1, I can do it. How? Minus 1 plus 1, right? Minus 1. Yes, sorry.
I don't understand the math. When you get negative 1/2 and then parentheses x to the 4th minus 1.
Yeah, if you distribute, you get that. You're factoring out a common factor. Common factor is 1/2. And I took a negative 1/2 because the leading term is negative. Factoring out, that's all. Factoring, 1/2 is there, 1/2 is here. So I just took it out. Common factor. All right, that's it. We're done, right? Factoring part is done. Can you tell me the zeros? What is the first zero? You know there is no zero from that factor, right? Because it is x squared plus 1. If you set it to 0, you get x squared equals negative 1. Solutions are not real, they are imaginary. So x squared plus 1 is out. Same thing when you do this problem. X squared plus 1 is out. There's no 0 from there. Remember that. X squared plus a number is prime. No real solution. So if it's plus a number, you don't get any 0 from there. Okay, because it's imaginary. But you can get a 0 from here and from there. What are the zeros? X equals 1 and x equals negative 1. Multiplicity is 1, 1. Crosses, yes. Yes.
So we just don't even bother doing x squared plus 1?
No. If it's plus, you don't bother.
If it's plus,
yeah. If the exponent is even and it's a plus number, then you don't bother. Like x to the 4 plus 1. Ignore it. X to the 6 plus 1. X squared plus 1. Those are all prime. Okay. Okay, crosses. Step 4. What's the maximum number of turning points? How many? What's the degree? 4, right? So, 3. Are we ready to graph? How many points we have? We have 3, right? We already plotted 1, which was the y-intercept. Now we have 2 more, which is negative 1, 0 and 1, 0. Correct? Right? And we know it crosses. So, we're getting only 1 turning point. That's because we don't know how it behaves. Less than negative 1 or more than negative 1, right? We're not finding any more points. There could be a turning point there. We don't know that. We're not caring about those. So just using the information we have, that's the graph. Looks like a parabola. Okay. So that's how you graph a polynomial function. You will get 2 questions on the test. 1 expanded U factor, and 1 factored. This is factored format. Can you tell me the end behavior? What's the degree? What's the leading coefficient? The number in front of it, which is 1, right? So how is the graph?
Left down, right up.
Left down, right up. Yeah? Okay, zeros. Zeros. From here, 0. From here, none. From here, -4. So from each factor, that's where you're getting the zeros. No 0 from there. Multiplicity? 2. Multiplicity? 1. Right? So what does it do? 2 touches. 1 crosses. Turning points. Oh, I didn't do y-intercept. What's the y-intercept? Sorry. Put x equals 0 in there. 0. If 0 is a 0, then y-intercept is also the same. 0, 0. Y-intercept is when x equals 0. So 0 times 1 times 4 is 0. Okay, maximum number of turning points? 4. Okay, can we graph? I have 0, 0, then I have -4, 0. And right end goes up, so it crosses, then it touches. Okay.
Why is the turning point 4?
Because degree minus 1, that's the formula.
Oh, okay.
N minus 1. So I recorded the second part of the